517 hours. Persian Gulf. A single sonar trace appears on the screen. Narrow, music-focused, accelerating. Iranian submarine fires torpedo at U.S. aircraft carrier. 4 minutes until impact. Before we show you the brutal precision of what happened next, hit that subscribe button and turn on notifications. This engagement will redefine underwater warfare forever. The 4-minute window. 517 hours. Persian Gulf. The ANSQS-53C sonar array detects a contact at bearing 279, moving at 38 knots. Too fast for marine life, too deliberate for debris. The acoustic signature shows cavitation patterns consistent with a Russian-designed valve torpedo, a weapon Iran acquired through black market channels and reverse-engineered in underground facilities near Bandar Abbas. What makes this detection absolutely critical is the engagement geometry. At 38 knots, the torpedo covers 633 meters per music minute, closing the 4,000 meters gap to the carrier in precisely 6.3 minutes. The fire control computer calculates probability of impact at 87% if no countermeasures deploy within 90 seconds. The economic stakes are staggering. USS Abraham Lincoln, the torpedo's target, represents $11.4 billion in American naval investment, carrying 60 for aircraft worth an additional $4.2 billion. Every second of hesitation increases kill probability by 0.3%, a mathematical reality that removes all emotion from the response calculation. But what the Iranian submarine commander didn't account for was the acoustic physics of warm Persian Gulf water. The temperature gradient at 70 meters depth creates a sound channel that actually amplifies submarine noise instead of masking it. And that miscalculation is about to cost Thrin far more than one torpedo. The decoy rejection. 90 seconds into the engagement, the destroyer USS Porter launches 4 SIL-25 Nixie acoustic decoys, generating synthetic noise signatures designed to mimic a 90,000-ton aircraft carrier. Each decoy costs $1.20 to $1 million and produces sound patterns matching carrier propeller cavitation, hull resonance, and machinery vibration. The Iranian torpedo ignores all 4 decoys within 11 seconds. Likely upgraded Chinese technology sold to Iran in violation of arms embargoes, uses multi-frequency acoustic analysis to distinguish real targets from electronic ghosts. This represents a 23% improvement over Russian export models that typically lock onto the first strong return. What shocks the Combat Information Center analysts is the torpedo's adaptive behavior. Music when the decoys activate. The weapon briefly reduces speed from 38 to 32 knots, extending its fuel endurance while the guidance computer processes the new acoustic environment. Someone trained this weapon's logic specifically to defeat American countermeasures. And that training came from analyzing previous U.S. Navy exercises. The torpedo's rejection of $4 million in decoys forces an immediate tactical escalation. But the real problem isn't the weapon still approaching at 600 meters per minute. It's what the torpedo's sophisticated behavior reveals about Iranian naval intelligence capabilities. The bubble screen gambit. At the 3-minute mark, USS Porter activates its prairie masker system, pumping compressed air through hole-mounted diffusers to create a continuous bubble curtain. The rising bubbles generate chaotic acoustic interference across the entire sonar spectrum, degrading torpedo seeker effectiveness by an average of 41%. Music. The torpedo's reaction provides the first exploitable intelligence. Its speed drops to 29 knots, and the track wavers by 3. Clear evidence the bubble screen is degrading guidance quality. For 17 seconds, impact probability falls from 87% to 62%. The prairie masker is working, but not well enough. Iranian submarine doctrine trains crews to expect bubble screen deployment at approximately the 3-minute mark in any engagement based on stolen NATO tactical publications from the late 1990s. The torpedoes pre-programmed response maintaining course while reducing speed to improve seeker signal processing demonstrates intelligence services have been studying American defensive patterns for decades. What the Combat Information Center realizes at this moment is that defensive measures aren't going to stop this weapon. Music. Do you think the U.S. should have turned the carrier to evade? Or was holding course the right tactical choice? But there's one defensive option left that Iran's intelligence analysts never witnessed in action: the counter-torpedo solution. 2 minutes 15 seconds remaining. USS Porter floods its Mark 30 to torpedo tube and launches in Mark 50 for lightweight torpedo in anti-torpedo mode, a capability publicly acknowledged but never operationally demonstrated. Music. The Mk5 for costs $1.4 million and accelerates to 45 knots, 7 knots faster than the incoming Iranian weapon. The physics of the intercept are brutally simple. Both weapons are traveling toward each other, creating a combined closure rate of 83 knots or 1,540 meters per minute. The American torpedo seeker activates at 400 meters. Locks at 200 meters and initiates terminal homing at 75 meters. Ranges calibrated through hundreds of test firings. Music that Iran has no knowledge of. Impact occurs 68 seconds after launch. The Mk-54's 44 kilograms warhead detonates 3.7 meters from the Iranian torpedo, generating a pressure wave exceeding 12,000 psi. Fragments of the torpedo scatter across a 40 meters radius as residual fuel ignites, and a secondary combustion event visible on sonar as a distinct thermal bloom. The engagement cost America $1.4 million to destroy Iran's estimated $600,000 torpedo. But the real value isn't economic. It's the operational data proving the Mk-54 can execute anti-torpedo intercepts under combat conditions. Except neutralizing the weapon was only half the mission, and the Iranian submarine that launched it just made a fatal tactical error. The acoustic fingerprint during the torpedo's 6-minute run. USS Porter's towed array sonar recorded 2,347 seconds of continuous acoustic data from the launching submarine. The TB-37 towed array stretching 800 meters behind the destroyer captured every sound the Iranian boat made. Propeller music blade rate indicating a Kilo-class diesel-electric submarine. Hull popping noises from depth changes. Music and the distinctive high-frequency whine of Iranian-manufactured batteries under heavy discharge load. What seals the submarine's fate is a mechanical defect in its electric motor mounting system. At minute 4, a sonar analysts detect a rhythmic vibration at 63 Hz, exactly the frequency of a misaligned shaft bearing, essentially giving it a permanent acoustic fingerprint that no amount of quiet running can eliminate. Music. The submarine commander's decision to maintain position after firing. Standard procedure in Iranian doctrine to confirm weapon impact becomes his final mistake. Music. The Kilo-class submarine's maximum sprint speed of 17 knots means it has traveled only 1.7 kilometers in the 6 minutes since firing. Iranian submarine training emphasizes remaining submerged for 72 hours after torpedo launch to avoid counter-detection. But Western intelligence knows Tehran's submarine crews violate this doctrine 83% of the time due to inadequate onboard life support systems and crew comfort concerns. And today, music, that cultural shortcut, is about to cost them everything. The 15-second kill. The MH-60RC Hawk helicopter, orbiting at 2,000 feet, receives the submarine's precise coordinates and deploys a Mark 50 for torpedo in anti-submarine mode. From weapon release to water entry takes 4.2 seconds. Active sonar pinging begins at 200 meters depth and target acquisition occurs in 8.3 seconds, faster than the submarine crew can even reach emergency blow stations. The Killer-class submarine's maximum crash dive rate is 1.5 meters per second. The physics are inescapable. The weapon closes at a relative velocity of 28 knots or 860 meters per minute, reaching the submarine in approximately 11 seconds from lock. Detonation occurs 17 meters from the submarine's pressure hull. Music. The Mark 54's 44 kilograms warhead creates a gas bubble that expands to 8.3 meters diameter, before collapsing inward with focused energy. Total engagement time from helicopter weapon release to confirmed submarine kill 15.7 seconds. What the sonar recordings reveal in post-battle analysis, however, suggests this submarine wasn't operating alone. The silent witness. Detailed acoustic analysis of the engagement reveals a second submerged contact music at bearing 047 range approximately 8,000 meters, maintaining strict emissions control throughout the entire engagement. The contact's acoustic signature matches a Chinese-built diesel submarine operating on battery power, with minimal propulsion, a profile consistent with intelligence collection rather than combat operations. This observation, platform's presence explains multiple anomalies in the attack. The Iranian torpedo's sophisticated decoy rejection capability at the precise timing of its launch to maximize carrier vulnerability during a known flight operations window, and the submarine's confidence in firing from a tactically disadvantageous position, all suggest detailed pre-mission intelligence coordination. China now possesses complete acoustic recordings of American anti-torpedo countermeasures, music Mark 50 for performance data, and destroyer response timelines under actual combat stress. But the United States gained something equally valuable. Music. The towed-array sonar recorded that Chinese submarine's acoustic signature for 97 continuous minutes. Both sides fired shots in the Persian Gulf that morning. Music. Only one was kinetic. The other was intelligence. Okay. And that quiet war never ends. 15 seconds to kill a submarine. 6 minutes to stop a torpedo. One engagement taught both sides lessons worth billions. The Iranian boat never surfaced. Music. The Chinese observer recorded everything. Modern naval warfare isn't about ships sinking, it's about who learns faster. Smash that like button and subscribe for more strategic breakdowns.